Before going to study detailed structure of atom, we see what is atom. The word atom came from Greek language. In Greek language, Thomas means smallest divisible particle and atomos means smallest indivisible particle. The ancient Greek philosopher Democritus once said that all matter is made up of atoms which are indivisible. Everyone agreed. But as he was a philosopher, he could not prove it. Even before Democritus, our Avai party said about an atom. Praising the Thirukural, she said, அணுவை துளைத்து ஏழு கடலை புகட்டி குறுக தரித்த குரல். Here the word anu means atom. The divisibility of atom is more difficult. She said like that. So from this statement we can have an idea about ancient Tamil people. Ancient Tamil people had also had an idea about an atom and its indivisibility. Both the Democritus and the Avai party have some similarities. Both are philosophers. Both of them did not have any proof, that is scientific proof for an atom. So the credit of discovering the atom actually goes to John Dalton, because he is the first one gives the scientific postulates about atom, in which one of the postulates stated that all matter is made up of atoms which are indivisible. Whenever we talk about atom or atomic structure, we cannot forget the name John Dalton, because he was the pioneer of atomic structure. In the beginning of first quarter of the 19th century, John Dalton proposed his postulates about an atom. At the end of the first quarter of the 19th century, Michael Faraday, a British scientist, while doing his research on electrolysis process, he saw that metals are dissociated and deposited. So he thought that atoms might have the subatomic particle in them. For that, he did an experiment in which he took a glass tube like in this video, and he took a particular gas molecules in that glass tube, and they were partially vaporized. Then he kept two electrodes, that is cathode and anode. Then he applied high voltage in between these two electrodes. He thought that a ray would be passing through it or any other changes would occur. But it did not happen because the ray is invisible. To make the visible rays, he produced a hole in the anode. Then inside the anode, he gave a coating of zinc sulfide. The property of this zinc sulfide is that it would give phosphorescence color in darken. Like he thought that the ray was visible, but the ray was very thin. Because of this, Michael Faraday said that John Dalton was wrong and the atoms are divisible. But he did not talk about any of its characteristic of the rays as strongly as he talked about it being divisible of an atom. In the beginning of third quarter of the 19th century, Henry Chisler, a German scientist, and he was also a glass blower, he wanted to do the same experiment what Michael Faraday done, and he wanted to do some changes in that experiment. That was, he reduced the pressure on that glass tube so that number of molecules will be reduced. Then he applied a high voltage in between these two electrodes so that he saw a full glow on the glass tube. Then he said, when he reduced the gas molecule, the number of molecules will be reduced. That molecules will receive the current, it emits electrons. That electrons will move from cathode to anode. So, the ray is only the negatively charged particles. Then he named the ray as cathode rays. A British physicist, JJThomson, measured the ratio of electrical charge to mass ratio by using cathode ray tube and applying electric and magnetic field perpendicular to each other as well as to the path of the electrons. When only electric field is applied, the electrons deviate from their path and hit the fluorescent plate towards a positively charged electrode. When only a magnetic field is applied, the cathode ray strikes the fluorescent plate in the opposite direction of the electric field. That is, in electric field, it moves in upward direction, but in magnetic field, it moves in downward direction. In the absence of electric or magnetic field, these cathode rays travel in a straight line. JJThomson, carefully balancing the electrical and magnetic field strength, it is possible to bring back the electron to the path which is followed in the absence of electric or magnetic field, and they hit the screen in a straight line path. JJThomson done accurate measurement on the amount of deflection observed by electrons on the electric field strength or magnetic field strength. So he was able to determine the value of E by M ratio. He found that E by M ratio value is 1.758820 into 10 to the power of 11 coulomb per kilogram. Here Me is the mass of the electron in kilogram and E is the charge on the electron in coulomb. JJThomson said that the amount of deviation of the particles from their path in the presence of electric or magnetic field depends upon the following points. They are: when the magnitude of the negative charge on the particle increases, the deflection in the presence of electric field or magnetic field is also increases. Second point, the mass of the particle decreases, deflection will be greater. Third one, if we increase the strength of the electrical or magnetic field, the deflection also increases. In this video, we see the discovery of protons. In the last video, we have seen the discovery of electrons. Even though many scientists were contributed to find one of the subatomic particle, that is electron, JJThomson gets overall credit to discover the electron because he found the characteristic of negatively charged particle and he named the particle as electron and he found the E by M ratio. Based on this, Goldstein thought that atom being electrically neutral in nature, it should be necessarily possess positively charged particles to balance the negatively charged electrons. Goldstein repeated the cathode ray experiment by using a perforated cathode and applying a high voltage under low pressure. He observed a faint red glow on the wall behind the cathode. Since these rays originated from the anode, they were called anode rays or canal rays or positive rays. Anode rays were found as stream of positively charged particles. Now we see the properties of canal rays. They are Unlike the cathode rays, mass of positively charged particles depends upon the nature of the gas present in the cathode ray tube. These are simply positively charged gaseous ions. The second one is the charge to mass ratio of the particles depends upon the gas from which these originate. Third one is the behavior of these particles in a magnetic field or electric field is opposite to that of observed for electron or cathode rays. JJThomson, an English scientist, just after the discovery of electrons and protons, proposed the first ever atomic model in the year 1904. Thomson's atomic model was also called as plum pudding model or the watermelon model. The embedded electrons resembled the seed of watermelon, while watermelon's red mass represented the positive charge distribution. The plum pudding atomic theory assumed that the mass of an atom is uniformly distributed all over the atom. Thomson proposed that the shape of an atom resembles a sphere having a radius of the order of 10 to the power of minus 10 meter. The positively charged particles are uniformly distributed with electrons arranged in such a manner that the atom is electrically neutral. Hope you understand the Thomson atomic model. In the next video, we will see the Ernst Rutherford model. Ernest Rutherford was a scientist from New Zealand who was interested in knowing how the electrons are arranged within an atom. He designed an experiment for this. Now you can see the experiment setup. This is source of alpha particles. Alpha particles nothing but doubly positively charged particles, that is helium 2 plus. To see the deflection of alpha particles by thin gold foil, he chosen the luminescence screen. In this experiment, Rutherford observed few spots on luminescence screen. If JJThomson model of an atom was true, Rutherford would have observed half of the alpha rays, that is doubly positively charged particles, would bounce back at an angle of 180 degree. As we already know, similar charge will repel each other, that is doubly positively charged particles would repel the positively charged proton, and the other half of the alpha rays will deviate from their path at some angle. It is due to the electrons, but that did not happen. But what he observed were most of the alpha particles passed through the foil. Some alpha particles were slightly deflected from their path. Very few alpha particles completely bounced back. From these observations, he concluded that the atom contains large empty space. There is a positively charged mass at the center of the atom known as nucleus. The size of the nucleus of an atom is very small compared to the size of an atom. The electrons revolve around the nucleus in a closed circular path called orbits. An atom as a whole electrically neutral, that is, number of protons and electrons in an atom are equal. So Rutherford's model of atomic structure is similar to the structure of solar system. Just as in the solar system, the sun is at the center and the planets revolve around it. Similarly, in an atom, the nucleus present at the center and the electrons revolve around its orbits or shells. According to electromagnetic theory, a moving electron should accelerate continuously lose energy. Due to loss of energy, path of electron may reduce and finally the electron should fall into the nucleus. If it happens so, atom becomes unstable, but atoms are stable. Thus, Rutherford model failed to explain the stability of an atom. Hope you understand the Rutherford's atomic model and its limitation. We'll see you in next video. Thank you. Bye.